Hello, this is my lab video for Physics 2211, section W10 for Lab 1, constant velocity. As for the problem that we were trying to solve with this experiment, it all revolves around an object such as this soccer ball moving at constant velocity between a model which absolutely has no F-net and is the ideal in terms of zero changes in velocity versus a real-life model which is prone to error, for example. Now, the question stated is how does the model at constant velocity using GlowScript and idle as methods to express said model compare to a real-life object in constant velocity, as shown right here using Tracker as an application to record the motion of said soccer ball, with position versus time graph as shown in the image right here. In terms of fundamental forces, the first one that comes to mind is Newton's first law, in which an object will stay in motion and is acted upon by a force from the opposing outside. Now, to quantify this, we use Newton's second law of the momentum principle, in which F net is equal to m net, or the change of velocity times mass will equal to F net, or the force summation of forces in the formula. Now, in terms of the stuff to utilize to get there, we use both the displacement formula and the change of velocity formula, in which the final position is equal to position initial plus v average times delta t, arguments of time, or in change of velocity formula, in which velocity final equals velocity initial plus F net over mass times delta t, or change in time. We can give a general prediction for the results of said experiment with both the model and the soccer ball, where they both move at a similar constant velocity. Now, in order to prove these predictions, we will both use Tracker in order to see the real motion of the ball, and GlowScript and idle to form the model. And now we will see both the soccer ball and the graphical representation of the position versus time through Tracker. With the utilization of Tracker, we can now show the real-time recording of the ball rolling across the floor of my apartment building as a real-time experimental model. Now, we see the origin of the ball, origin at the center of the ball in order to indicate the position of the ball being at 0, 0 and moving in the negative direction as shown here. And we approximate the distance based on the diameter of the ball, which I measured using the blue bar up right over here. And this is the origin. Now, as you can see in the video, the ball rolls across the floor as I manually applied all 24 points of the thing, and it's shown right here versus the time and x table right here, but it's also shown in this graphical model where it slightly curves up. Now, in order to show the model, we're going to move to GlowScript and idle as a demonstration of a model where it's a perfect straight line with no effect. With given a model script to use for GlowScript, I used that and made slight changes which I will go into the elaboration in a second. But to show the model program, right here, as you can see, the blue ball moves left negatively, similar to the real-time motion in the experiment, and as we can see in the position versus time graph, it is very similar, except this time it is completely straight, which I will show a comparison of the two also in just a second after explaining this code 4 that I changed. Now, as for the changes in the code, in order to better reflect the momentum principle, I did both the change in velocity and change in position formula in order to more accurately describe said formula with F net over mass times delta t and ball velocity times delta t. Now, I also implemented the initial position and initial velocity right here as grabbed from Tracker, and because Tracker, the time frame for the Tracker was only 0.8 seconds, I also indicated that within the loop. Shown in our final conclusion data, we can see that the experimental position and model position data right here, in the experimental position curves slightly up versus the model position, which, based on the coding, is shown to be straight linear. Now, as an explanation for this change in position, the F net has to be a different value other than 0 in the positive direction, as it causes the ball's position moving into the negative to be slightly less than the model position, which we can determine to be most likely the frictional force of the floor moving on the ball, causing it to be slightly less negative in position. Now, if the axes were flipped, for example, then the experimental position would be shown to be at a greater negative position than the linear position, which we can deem to be inaccurate as there is no indicated force, as seen by the video, to cause the ball to move further into the negative direction than the model position. Overall, with an extension of our conclusions based on our data about the experimental position having to have an F net force in the opposing direction of its motion in order for its position to be less negative than the model position, we can come to the extension of Newton's second law on F net force, as F net is the summation of forces, and it's impossible to determine the forces that make up F net unless given the situation of the real-life model. In this case, because it was rolling across the floor, we were to determine that the opposing direction of the force had to be frictional force, causing the experimental position to be less negative than the model position. Thank you.